Section 3.3 is a little bit harder of a section because you're taking so many concepts and putting them together. And so let me show you a little bit. Number 8's having a lot of questions, so let's see if this will help us out with this. It says, given the polynomial, write it in factored form. So what we're trying to do is we're trying to break this down. Now there's 2 approaches to this, and I'm going to work through those with you here. For number 8, the quickest approach for this one is I notice that I have quite a few x's and I have things that are being divided by 4. So I think this one actually will factor out. Let's see how it does. And so looking at this problem, I am going to factor by grouping. So I'm going to look at the front 2 and I see that they both have an x in common. And the smaller of the 2 is x squared, so I'm going to pull in x squared out. And this leaves me with x plus 4. Now in the back half, 4x and 16 both are divisible by 4, so I'm going to pull a 4 out of that, and that gives me an x plus 4. And so then you'll notice that we both have a grouping of x plus 4 in common, so I'm going to pull that out front, leaving me with x squared plus 4 in the back. Now my goal is to get this as a product of linear factors, so that squared, I can't leave it. Now what this is if this had been x squared minus 4, that would be the difference of 2 squares. But let me come over here and show you what this looks like. If I were to set this equal to 0 and solve, I would get x squared equal to -4, square root both sides, and that gives me x equal to 2 plus or minus, and then that negative is that I, like we talked about in the last chapter with complex numbers. So the linear factors that would come out of this would be x plus 4, and then x minus or x plus 2i and x minus 2i. And then this would be my fully factored polynomial. And it says to write as a product of linear factors, so I would not be entering 2i, -2i, and -4. I would be entering these factors here. It already has p of x equal to 0. Now another approach to this is to take this polynomial, let me go ahead and write it down here, and to use that rational zero test to help us with this. Now it did factor really nicely, but let me revert back to some of the content we've done in this section. The rational zero test says if you take the back number and the front coefficient, so that would be 16 over 1, and look at the factors of these two numbers, this would give you the factors of 1 and 16, positive and negative, 2 and 8 and 4, all divided by 1. So my possible real zeros for this polynomial would be 1, I'm dividing 1 by 1, 2 by 1. You're just dividing all your stuff in your top by what's in the bottom, and it gives me these options. And so let's apply that. Now since all of these do look like they're almost all divisible by 4, I am going to start with 4 and try it using my synthetic. So 1, 4, 4, 16. I'm just going to quickly kind of do my synthetic. Oh, it's getting pretty big. So that is not going to give me a 0. Let me try a -4 though, because hopefully that negative, as I add and multiply along the way, will reduce my numbers down, because my goal is to get a 0 for the remainder. 1, 4, 4, 16. So that gives me, let's see, add. Oh, these numbers are already looking better. That should have been a 0, excuse me, 4, and then -16. So that does give me a 0. So this shows me that -4 is a 0, and that would be a factor of x plus 4. This started out as x cubed, so x squared, and I would be left with x squared plus 4, just like we did in the previous part where I was just factoring it. Then if you take that x squared plus 4 and set equal to 0 and solve, just like you saw before, you get x to be, excuse me, getting ahead of myself, plus or minus 2i, and then you could rewrite this as factors of x plus 5, x plus 2i, x minus I, and x plus 4. And so this is 2 different approaches to the problem. I do think the factoring goes a little bit easier because of your coefficients, but I also want to show you in regards to 3.3 on how the possible zero test also helps you with that. So let me know if you have any further questions on number 8.